Photoelectric experiment, a parallel beam of monochromatic light with power 200 watt. So what is the power? 200 watt. That means 200 joules per second is incident on a perfectly absorbing cathode. So it's absorbed. Okay, of work function 6.25 electron volt. The frequency of light is just above the threshold frequency, so that the photoelectrons are emitted with negligible kinetic energy. Okay, so this is basically h nu or hc by lambda, because each photon is just barely able to eject an electron. So therefore this is 6.25 electron volt is the energy of each incident photon. So therefore we can find out number of photons falling per second in 1 second is equal to 200 joules divided by 6.25 electron volt, which is equal to 200 joules divided by 6.25 into 1.6 into 10 to the power minus 19 joules. So how much it is? 200 into 10 to the power 19 by 6.25 into 1.6. okay, joules and joules is gone. So 6.25 into 2 is 15, sorry 20, 6.25 into 2 is 12.5. 12.5 into 2 is 2 is 25, 50, 100, 200, 2 to the 4, 8, 16. So this is basically into 1.6. okay, 12.5, 25, 50, and this becomes 100. okay, so 6.25 into 1.6 is basically 10. So therefore it's going to be 2 into 10 to the power 20 photons per second. Now assuming that the photoelectric emission efficiency is 100%, so that means how many electrons are getting emitted? So that means the number of electrons which get emitted is 2.20 electrons. So 2 into 10 to the power 20 electrons get emitted per second. Now a potential difference of 500 volt is applied between the cathode and the anode. All the emitted electrons are incident normally on the anode. Now these electrons are incident normally on the anode. Now what is the kinetic energy of each electron? This is equal to 500 electron volt, and now they are being absorbed by the anode. So therefore h by lambda is the like change in the momentum, because it's going by h by lambda and it gets absorbed, so the now momentum becomes 0. So therefore h by lambda, okay, into h by lambda into okay, or now it's because it's like electrons are getting emitted, so h by lambda we are not so the momentum is going to be root over 2 mass of electron into k, kinetic energy of electron. Okay, so therefore 2 into 10 to the power 20 electrons with their change in momentum, which is root over 2 into mass of electron into the kinetic energy of electron. Okay, and this entire thing happens in 1 second, so therefore divided by 1 second is going to be equal to the force. So therefore the force is going to be 2 into 10 to the power 20 into root over 2 into 9 into 10 to the power minus 31 into 500 into 1.6 into 10 to the power minus 19. Okay, so the force becomes we have, this is 1000. Okay, so this goes and this becomes 16. So 10 power minus 31, 10 to the power minus 19, it's going to 10 power minus 50. So this becomes 10 to the power minus 48. Okay, so therefore F becomes 2 into 10 to the power 20 into, this is 3 into 4. Okay, 9 into 16, so 3 into 4 into 10 to the power minus 24. Okay, so this becomes 2 into 3 is 12, 6 into 4 is 24. So 24 into 10 to the power minus 4 newtons. So therefore the value of N is going to be 24. That's that.